viewers, so we have a question here. When one arm of the YouTube manometer is connected to this gas supply, the level of mercury in the two arms of the YouTube are shown in the diagram below. If the atmospheric pressure is 76.0 cm mercury, what is the gas pressure? Now, looking at this diagram, we notice that the gas supply pressure is greater than the atmospheric pressure. So when the gas supply pressure is greater than the atmospheric pressure, we have the formula to be P equal to H plus H, where uppercase H is the atmospheric pressure and lowercase h is the pressure difference. So from the question, we're given that the atmospheric pressure H is equal to 76.0 cm mercury, and for the pressure difference, now if you notice, the total height of the mercury is 13.4 cm and the height on the gas supply arm is 3.5 cm. So for us to get that difference, that change, look at the change here. For us to get this pressure change, we'll simply do, for us to get this pressure change, we'll simply do 13.4 minus 3.5, and that will give us H to be equal to 9.9 centimeter. Therefore, the pressure of this gas is simply 76.0 plus 9.9, and the pressure is given by 85.9 centimeter mercury. So try this. Number 2, you can pause the video and try solving this. Okay, so from the question, in the diagram below, if the atmospheric pressure is 760 millimeter, what is the pressure in the chamber G? So we're given the atmospheric pressure to be 760 millimeter. Now it's millimeter of mercury actually, because the liquid inside this is mercury, you get. Then looking at this again, the gas pressure is greater than the atmospheric pressure, so the formula is given by P equal to H plus small h, right? So how can we get small h? Small h is simply by doing 10 minus 3, and that will give us 7 centimeter. Now comparing the SI unit of small h is cm, and the SI unit of uppercase H is millimeter. So we have to convert this to cm, or you convert this to millimeter. So converting this to cm, recall that 10 millimeter is equal to 1 centimeter. So for us to convert millimeter to cm, simply divide by 10. To 760 divided by 10 will give us 76 centimeter mercury, right? So that our final answer will be P equal to 76 plus 7, and that will give us 83 centimeter mercury. Try this. Okay, in this question, we're given the atmospheric pressure to be 76 cm mercury, and if you notice, in this case, we're given the pressure difference, because from this point to this point is 3 cm, so that is the pressure difference. So H is equal to 3 cm. Looking at this, the gas pressure is also greater right, than the atmospheric, so that P is equal to what? H plus small h. So simply 76 plus 3. My answer is simply 79 centimeter mercury. So question number 4 is actually the same thing with the previous example. So you can pause this and try solving this. So having said that, the atmospheric pressure is still 76 cm of mercury. The pressure difference is what? 10 cm. Now, the gas pressure is still greater than the atmospheric, so rising P is equal to H plus small h, so that P is simply 76 plus 10, and the answer is 86 centimeter mercury. This question number 5, we're given that in the diagram below, calculate the pressure of the gas supply if the atmospheric pressure is 70 cm of mercury. So we're given H to be 70 cm mercury. So looking at this, our pressure difference is 6 minus 2, and that will give us 4 centimeter. And now the gas supply is less than the atmospheric. The atmospheric pressure is greater than the gas supply. That is why the liquid mercury is higher in the gas supply limb. So the pressure is given by H minus small h. So this formula is given when the atmospheric is greater than the gas supply or gas supply pressure. So what is H? H is 70 minus 4. So that our answer will be 66 centimeter mercury.